In this video, we're going to look at a measure of error, which is called standard deviation. Now, if you've seen the video we created on mean absolute deviation, MAD, this is the other common form of measurement of error, standard deviation. Standard deviation is a measure of average amount of average error. Now let me show you here what we had for a conversation back in mean absolute deviation, in case you have not seen that yet. One of the challenges we have when we look at variation is the situations where we exceed the forecast or come up short. They can tend to wash each other out. And what we're talking about here is, let's say I've got a forecast for 4 periods of 8 per month, and my sales have been 4, 12, 6, and 10. This is the same numbers we used for MAD. So the forecast was 32, the actual sales was 32, and it looks like we were perfect. But the reality is, we look at the numbers up here and we recognize that each period we ended up, in the, if we looked at the error each month, in the first one, we came up 4 short, and in the second one, we were 4 high. We exceeded the forecast by 4. We came up short by 2, and went by the forecast by 2. So they wash each other out. So the question becomes, how do I account for the fact that pluses and minuses can offset each other? In MAD, we said, we get rid of the effect by ignoring the sign, taking the absolute value. We don't care about direction. In standard deviation, what we do is we square the number. So we take -4 and we multiply it by -4 and we get 16. 4 squared is 16. -2 squared is 4. And if you don't remember your math, squaring is multiplying a number by itself, and 2 squared is 4. So if you look at these numbers, we've got an artificial number, 16 and 4. We got to deal with that, but we've essentially gotten rid of the sign. So the formula for standard deviation looks like this. It's the square root of the sum of actual minus forecast squared divided by n, the number of data points minus 1, which we'll explain in just a moment. So if we look now at this, A is actual, F's forecast, we do A minus F first, and that gives us the error. And then we squared it second to get rid of the sign. And then the third thing we do is add them all up. So we're going to take 16 plus 16 is 32, plus 4 is 36, plus 4 is 40. So this is the third step. And then we're going to divide the 40 by the number of data points, 1, 2, 3, 4, minus 1 or 3. The reason we're doing n minus 1, this comes out of statistics, is that typically when you have less than 32 data points, you run a higher risk of one data point having an overly high influence or overly low influence on all the data. And we've learned, and I don't know all the math behind it, but if we do one less data point, it tends to start offsetting the impact one number can have. So now we do 3 into 40, okay, which is our fourth step we're going to do here. So this was adding them up. Fourth is the division right here. So 40 divided by 3 gives us 13.33. And then the last thing, because this number is high, because we squared it, you could argue we have to bring it down now by taking the square root of the 13.33. So let's see if I remember how to do this on my calculator. I'm going to hit the square root button, type in 13.33, hit equals, and I got it backwards. So let's do 13.33 and hit the square root button. And it comes up 3.65. Okay? So that is our average amount of error using standard deviation. Now, if you've seen the MAD video, MAD came up with an average variation of 3, okay? And this way came up with 3.65. If I'm correct, I would look this up in textbooks or whatever before I would take this anywhere. But my understanding is standard deviation is mathematically more average or more accurate, okay, than MAD, although MAD is more commonly used in a lot of cases. But there's a rough correlation that I believe when you take MAD and add another 25%, you get a rough correlation to standard deviation. So if I take 3.0 times 1.25, I get 3.75, which is a rough, not perfect, but a rough approximation to standard deviation. But again, standard deviation is mathematically more accurate. It's just another way of forecasting error.